The Bell Boeing V-22 Osprey is an American multi-mission, tilt-rotor military aircraft with both vertical takeoff and landing VTOL and short takeoff and landing STOL capabilities. It is designed to combine the functionality of a conventional helicopter with the long-range, high-speed cruise performance of a turboprop aircraft. In 1980, the failure of Operation Eagle Claw during the Iran hostage crisis underscored that there were military roles for which neither conventional helicopters nor fixed-wing transport aircraft were well suited. The United States Department of Defense (DoD) initiated a program to develop an innovative transport aircraft with long-range, high-speed, and vertical takeoff capabilities, and the Joint Service Vertical Takeoff/Landing Experimental JVX program officially commenced in 1981. A partnership between Bell Helicopter and Boeing Helicopters was awarded a development contract in 1983 for the V-22 tilt-rotor aircraft. The Bell-Boeing team jointly produces the aircraft. The V-22 first flew in 1989 and began flight testing and design alterations. The complexity and difficulties of being the first tilt-rotor for military service led to many years of development. The United States Marine Corps USMC began crew training for the V-22 Osprey in 2000 and fielded it in 2007. It supplemented and then replaced their Boeing Vertol CV-22 Knights. The U.S. Air Force USAF fielded its version of the tilt-rotor, the CV-22 in 2009. Since entering service with the Marine Corps and Air Force, the Osprey has been deployed in transportation and medevac operations over Iraq, Afghanistan, Libya, and Kuwait. The U.S. Navy planned to use the CV-22 for carrier-on-board delivery duties beginning in 2021. The failure of Operation Eagle Claw, the Iran hostage rescue mission, in 1980 demonstrated to the United States military a need for a new type of aircraft that could not only take off and land vertically but also could carry combat troops, and do so at speed. The U.S. Department of Defense began the JVX aircraft program in 1981 under U.S. Army leadership. The defining mission of the USMC has been to perform an amphibious landing. The service quickly became interested in the JVX program, recognizing that a concentrated force was vulnerable to a single nuclear weapon. Airborne solutions with good speed and range allowed for rapid dispersal, and their CV-22 Knights were wearing out. Without replacement, the USMC and the Army merging was a lingering threat, akin to President Truman's proposal following World War II. The Office of the Secretary of Defense and Navy Administration opposed the tilt-rotor project, but congressional pressure proved persuasive. The Navy and USMC were given the lead in 1983. The JVX combined requirements from the USMC, USAF, Army, and Navy. A request for proposals was issued in December 1982 for preliminary design work. Interest was expressed by Aerospatiale, Bell Helicopter, Boeing Vertol, Grumman, Lockheed, and Westland. Contractors were encouraged to form teams. Bell partnered with Boeing Vertol to submit a proposal for an enlarged version of the Bell XV-15 prototype on February 17, 1983. Being the only proposal received, a preliminary design contract was awarded on April 26, 1983. The JVX aircraft was designated V-22 Osprey on January 15, 1985. By that March, the first 6 prototypes were being produced, and Boeing Vertol was expanded to handle the workload. Work was split evenly between Bell and Boeing. Bell Helicopter manufactures and integrates the wing, nacelles, rotors, drive system, tail surfaces, and aft ramp, as well as integrates the Rolls-Royce engines and performs final assembly. Boeing Helicopters manufactures and integrates the fuselage, cockpit, avionics, and flight controls. The USMC variant received the V-22 designation, and the USAF variant received CV-22. This was reversed from normal procedure to prevent USMC Ospreys from having a conflicting CV designation with aircraft carriers. Full-scale development began in 1986. On May 3, 1986, Bell Boeing was awarded a $714 billion contract for the V-22 by the U.S. Navy. At this point, all four U.S. military services had acquisition plans for the V-22. The first V-22 was publicly rolled out in May 1988. That year, the U.S. Army left the program, citing a need to focus its budget on more immediate aviation programs. In 1989, the V-22 survived two separate Senate votes that could have resulted in cancellation. Despite the Senate's decision, the Department of Defense instructed the Navy not to spend more money on the V-22. Multiple studies of alternatives found the V-22 provided more capability and effectiveness with similar operating costs. The Clinton administration was supportive of the V-22, helping it attain funding. The first of 6 prototypes first flew on March 19, 1989 in the helicopter mode and on September 14, 1989 in fixed-wing mode. The third and fourth prototypes successfully completed the first sea trials on USS Wasp in December 1990. The fourth and fifth prototypes crashed in 1991–92. From October 1992 to April 1993, the V-22 was redesigned to reduce empty weight, simplify manufacture, and reduce build costs. It was designated V-22B. Flights resumed in June 1993 after safety changes were made to the prototypes. Bell Boeing received a contract for the Engineering Manufacturing Development (EMD) phase in June 1994. The prototypes were also modified to resemble the V-22B standard. At this stage, testing focused on flight envelope expansion, measuring flight loads, and supporting the EMD redesign. Flight testing with the early V-22s continued into 1997. Flight testing of 4 full-scale development V-22s began at the Naval Air Warfare Test Center, Naval Air Station, Patuxent River, Maryland. The first EMD flight took place on February 5, 1997. Testing soon fell behind schedule. The first of 4 low-rate initial production aircraft, ordered on April 28, 1997, was delivered on May 27, 1999. The second sea trials were completed on board USS Saipan in January 1999. During external load testing in April 1999, a V-22 transported the lightweight M777 howitzer. In 2000, there were 2 fatal crashes, killing a total of 23 Marines. And the V-22 was again grounded while the crash's causes were investigated and various spots were redesigned. In June 2005, the V-22 completed its final operational evaluation, including long-range deployments, high-altitude, desert, and shipboard operations. Problems previously identified had reportedly been resolved. U.S. Naval Air Systems Command (NAVAIR) worked on software upgrades to increase the maximum speed from 250 knots 460 kilometers per hour, 290 miles per hour to 270 knots 500 kilometers per hour, 310 miles per hour. Increase helicopter mode altitude limit from 10,000 feet 3,000 meters to 12,000 feet 3,700 meters or 14,000 feet 4,300 meters. And increase lift performance. By 2012, changes had been made to the hardware, software, and procedures in response to hydraulic fires in the nacelles, vortex ring state control issues, and opposed landings. Reliability has improved accordingly. An M-22 landed and refueled on board Nimitz in an evaluation in October 2012. In 2013, cargo handling trials occurred on Harry S. Truman. In October 2015, Navarre tested rolling landings and takeoffs on a carrier, preparing for carrier on-board delivery.